Yes, am I audible to all of you? Sara, Siddhika, Harsha?
Yes, ma'am.
You haven't found it, Harsha? Cross product class?
Yes, ma'am.
Okay, I'll share then, Harsha.
Okay, ma'am.
I'll share.
Thank you.
Now see, we'll start with unit 3, that is laws of motion. So unit 1 is dimension analysis and unit 2 is kinematics, which we started. Motion in 1D, motion in 2D. Then unit 3 we are starting, that is where we see the cause of motion. See, continuously we were talking about the motion which were occurring, right? Velocity was moving, acceleration was there, everything we had studied. Motion in 2D also we had seen, but nowhere we ever discussed why was the motion occurring. So in unit 3 we considered the cause of motion. So basically this lesson, laws of motion, this deals with the cause. What is actually causing the movement here? Why is your body even able to start itself? Even if it has initial velocity as 0, it has acceleration. So due to acceleration, why is it able to move? Or if it has started its motion, then why is it stopping now? So all these things we will discuss. So today we'll try to focus on the Newton's laws only, laws of motion, which you have already studied in your lower classes, but we'll have to do it in a little bit detail in your class 11. So first comes the concept of inertia. So inertia, some students confuse inertia as a force. They think inertia is a force which is being applied on the object, or the object is being stopped by it. Inertia is just a property. It's not a force. So it was introduced by Galileo. This is written also. Definition says that inability of the body to change to its state of rest or uniform motion by itself. What does this mean? This means that, see, if the body is executing a certain motion, let's say the body is moving in a straight line, let's say the body is moving in a particular circular motion or anywhere. So the body is able to maintain its state of motion. Or if, let's say, I have taken this pen and I've kept it over here. This isn't moving. This pen is not moving. So this is able to maintain its state of rest. So that property we call it as inertia. This is not the force which is stopping it. Forces are different. There will be a gravitational force which will be acting downwards. There will be a normal reaction which will be acting perpendicular. Some other friction force would also be there. Forces are different. Inertia is just a property because of which, or we just coin or term this property as inertia. All right, so please be clear, this is not a force. I'll write this also. It's a property of the body, not force. And it depends upon the mass of the object. Fine. If your body has a little mass, inertia will be less. If the body has a lot of mass, a bigger object, then inertia will also be more accordingly. So inertia, these are the few basic points of inertia. Now types of inertias are different. Before coming to types of inertia, Newton's first law is about inertia only, the concept of force. The Newton's first law introduces you to the concept of force. This means, this is basically, first law is all about inertia. So if you study about inertia in detail, it means you are studying about the Newton's first law. Before coming to Newton's first law, we will discuss the types of inertia. Inertia of rest, inertia of motion, inertia of direction. Now, inertia of rest means what? Rest means if the body is at rest, suppose the body is at rest, the body will continue to remain in the state of rest. See, now I have not applied any force. So the body is still in the state of rest. So body is still in the state of rest. Suppose I have applied a force here. Now the body has started moving, right? If I'm applying a force, now the body has started moving. But when no force was applied, it wasn't moving. Means the forces balanced each other, that is a different thing. But the body is able to maintain itself unless and until you are making this body move by yourself. So that is inertia of rest. If a particular body is there, see, different forces act on it. We have to study about forces in detail only in this lesson. Suppose gravitational force is acting downwards. Normal reaction, we will see this. What is normal reaction? This is acting upwards. Some other friction forces acting, some other friction forces balancing. That is, we have different types of friction also. So static friction is making the body stay. So all the forces are balancing each other and the body is not moving. How to write this up, we will see. We have free body diagram, so we will see that after. So when but the body is not moving. So if the body is not moving, it is balanced by all the forces. The body will continue to remain in its state, provided that no force is acting, no external force. Now suppose if I intentionally apply a force F here, suppose this is present, I intentionally move it. Now you can see motion is occurring. So it is disturbing the state of rest, that is inertia of rest. So external force is different. When you talk about external force, that is different. Suppose a body is moving. So this was moving. Let's say this is moving, this is moving. But now it has, let's say it has stopped at a point. It is moving, moving, moving. It is stopped at a point. So why did it stop? It was moving because of inertia of motion. The body was moving because of inertia of motion. Body will tend to maintain its state of motion. Body will keep on moving. It will keep on moving. It will never stop because of inertia of motion. It will only stop because of external force. So here, if the body, I had rolled it and it had stopped at this point, why do I say this is external force? Because friction is the force which is now acting and which is making the body stop, not letting the body move. But before friction could act, what happened? The pen was able to move, it moved, until as soon as friction force occurred, it's changed its state, right? So this is what is known as inertia of motion. If the body is moving, the body, if suppose, let's say even a car, if a ball, best example is a ball rolling. If you have a ball rolling, so what will happen? This will keep on moving, this will keep on moving, and it will stop automatically when the friction force will come. That is inertia of motion. Body tends to maintain its state of motion. Last is inertia of direction. Inertia of direction means, suppose I have taken an object and I have applied a force initially. Now the body is moving in a circular path. The body is covering its circular path. Continuously, the body is covering its circular path. Now, until and unless, suppose if what I have done, the body is moving in a circular path, I have applied a force at one point. What will you notice? The body which was moving like this, now it moves off tangentially. What has happened over here? The direction has changed. The direction has changed. Means one direction which was maintained originally by the body, because no external force was there, absence of external force was there. So when particular external force occurred, the direction changed. But before application of the external force, the body was maintaining its state of inertia. That is its inertia of direction. Body will have the tendency to remain in that same direction. Suppose the body is moving in a straight line, the body will continue to move in a straight line. You won't see the body changing its direction. If the body is changing the direction once moving, it means some external force has occurred in your system. Some external force. It could be viscous force of air, because if it's, suppose you have thrown a ball on the floor, you have rolled a ball is moving in a straight line, but you see the ball has turned its path. Then it is possibly because of the viscous force of air that threw the ball in an opposite direction, because of which it turned its path. So in the absence of external force, body will move in a straight line. This is what is inertia of direction. Means the body will continue to maintain its state of motion. And for disturbing all these states of rest, motion, direction, external force is needed. Coming back to the Newton's law. So Newton's law says the same thing. Newton's law says that whatever is the body's state, State can be three. It can be at rest. It can be in motion. It can be in a particular direction. That is what is meant by the state. When we say no state of a body, state means this only. State means either the direction, right? All these things, or the motion, or at the state of rest, we say state of motion, we say state of a particular direction, we say. So Newton's first law says that if a particular body has one state, one fixed particular state, then the body will remain in that state only. In rest, so it will remain in rest. In motion, so it will remain in motion. In a particular direction, it will remain in a particular direction. Till when? Till the time a particular external force is applied in your system on the body. That external force will change only the inertia. So Newton's first law introduced the concept of force. Body will maintain its inertia unless an external force is applied on the body. An external force can change inertia of the body. Note down all these points. Then we'll discuss some more points. This is your chapter 5th of NCERT. A total 8 chapters are there in your first book, part 1. So part 1 we should completely good. Who is this Redmi 9C? Please come with your real name. Please change your name.
Ambika Kumari Taspuria.
Yes.
Ambika Kumari Taspuria, my full name. Ma'am, not coming your sound. Sound
Second, inertia depends on the what of the body.
Yes, Martin, can you repeat?
Inertia depends on the mass of the body.
You're asking about this statement, inertia depends upon
Yeah,
mass of the
yeah,
body.
yeah.
See, inertia depends upon the mass of the body means, see, it's a property that we know. This is not a force that the magnitude should change or what. But when we say no, inertia depends on the mass, this means if you have two objects, let's say a small ball you have, a bigger heavy box you have. Now, the amount of all the forces which are required to balance the body, or the entire property that is required by the body to remain at a particular point or at a particular state, that will be more in the huge object, that is in the box. Whereas for the ball, it will be less. So it means if you have two, let's say two objects like a ball and a box, the amount of force, that external force that will be required to remove the state of inertia, it will be more in the box because of its mass. So that's why inertia also depends upon the mass, because inertia is a property. It will act according to the forces which are being applied, all the forces which are being balanced, and force depends upon mass. So therefore we say inertia also depends on mass. Also, Martin, you can relate it with this. Like if a ball is there and a box is there, a heavy box is there and a light ball is there. So which will automatically stay at its position by own? What do you think? The heavier box will not, in your home also, the heavier furniture stay, or the light toys or balls stay? The heavy furniture stay only, no, because of inertia. Because the resistance provided to the heavy object is more. That's why we say inertia depends on the mass of the body. Is it clear, Martin?
Yes, ma'am.
Ma'am, not coming sound your.
Done class? Still here?
Yes, ma'am.
Yes, ma'am.
See, inertia, types of inertia we have done. Now, one concept related to it, that is momentum. So momentum is also a very basic topic, and momentum questions will be used. Because formula is very easy. The formula of momentum is very easy. Look here. Momentum, basically the amount of motion in a body. What is meant by this? Amount of motion in a body means, suppose I have thrown a ball. Let's say I have thrown a ball. That ball is moving, it's moving. And then what is happening once the ball is moving? I have applied a very little force on the ball. But what I'm noticing is that ball is able to cover a larger distance. What is the reason? Why is the ball able to cover a larger distance? The reason is that the momentum in the body is so much, means amount of motion in the body. That is, the body has gained enough momentum so as to cover a larger distance that was required. That's what we call as momentum. So suppose one question is there, a very famous question, which we'll try to discuss also. A block is there and you shot a bullet, like a gun you have fired and a bullet has been shot. The bullet is moving, it pierces the block, and along with its motion, it is making the block also move. In this case, we will say that the body is having a lot of momentum. The small bullet is having a lot of momentum. Bullet size is also very less because speed is more. Because the speed becomes more, so it gains so much momentum that it sways away the block also along with itself. So this amount of motion in the body which is left or which is contained, amount, that measurement is known as momentum. Basically, we take it as the product. Momentum, we represent it through P. Momentum, this is represented through P. It's a vector quantity. Direction will be there. Whatever is the direction of velocity, take the direction of momentum. If velocity is towards right, momentum is also towards right. So momentum is the product of mass into velocity, because see, momentum will depend upon the mass of the body. If a lighter object is there and if a heavier object is there, amount of motion in one body will be more, amount of motion in the second body will be less. Like this we have. Then it depends upon the velocity. If a body is moving with a very high velocity, it will gain a lot of momentum. The amount of motion that is contained within the body. Amount of motion containing means the tendency to cover a larger aspect, to larger distance without being stopped. That is what is meant by the amount of motion in the body. And that is what we call as momentum. And this is the basic formula of momentum, mass into velocity. P is what? P is momentum. M is the mass of the body. And V is the velocity. Velocity of the body. Fine. Vector quantity. So do not forget to put a vector sign. It means you have to tell the direction. Whenever you're talking about vector quantities, we have studied vectors so much in detail. You shouldn't miss writing the direction. All your marks will be lost if you do not mention the direction, because that makes the vector incomplete. How do you then distinguish between a scalar quantity and a vector quantity? Fine. And direction is same as velocity. You don't even need to find out anything different. If two objects are moving in opposite direction, this is having 5 meters per second, this is having 2 meters per second. So net velocity is 3 meters per second, 5 minus 2 along the velocity, that is the heavier velocity with high magnitude. So direction of momentum will also be towards the right hand side. This is how you solve it. Regarding the SI unit, see, without even discussing, this is the formula, this is the quantity. What should be the SI unit? Tell me in the chat column quickly, all of you. Formula is given, you know, individual SI units for each. So combined SI unit should be what? Meter per second. Kg meter per second. Very good, Harsha. See, Sarah, meter per second is just for velocity. You cannot ignore mass, no? Mass is SI unit is kg. So mass is SI unit, that is kg, multiplied to the SI unit of velocity, that is meter per second. So that becomes kg meter per second. All right, not just meter per second. So this becomes kg meter per second. You have to use this SI unit. You have to mention the directions. I'm telling you again. Directions, see, you do not have so difficult directions in your class 11. You just have to mention right, left, towards, point A, towards point B. Like this in any language, you can just specify. It's not necessary to be I cap, J cap, K cap every time. Suppose a very basic question is there. This is that a body of mass 10 kg is moving with a velocity of 5 meters per second. Calculate its momentum. What will be momentum? Momentum is mass into velocity. Here, the only scalar quantity is mass. So mass is 10, velocity is 5. That becomes 50 kg meter per second. This is how we have to solve all the questions regarding it. So if momentum is changing in your object in the throughout the motion, if you are seeing that the momentum is being changed, value of mass and velocity won't change. Velocity can even change, but the mass of object doesn't change. If mass of object is changing, that makes a different theory, which you don't have to go into the details of. It means your inertia is changing. Momentum is changing means mass or velocity, either your velocity is getting lesser, or because of external force, you are having something. So it means if mass is the factor, inertia will change. Or one thing else that can happen is that external force is being acted into your system. Suppose I am moving this. Suppose this is being moved. This is moving at its own speed. So it is having certain value of momentum, by which it is moving. The value of momentum is there with which this is moving. It is moving. Suppose this is moving fast. Fine, look at this. This is moving fast. Now I have stopped it in between. So now what will happen? Initially, it had a lot of momentum. It had a higher velocity. It was moving fast. But as soon as external force was applied onto the system, it stopped. It means external force is acting in your system, which is changing the momentum. So these 2 points you should just keep in the back of your mind. These are not very important for your exams. Just have it in the back of your mind, just in case for your MCQs. That completes your first law, which is all about inertia. It's all about inertia. Momentum is actually linked. Small portion of momentum is linked with inertia, which we have seen. A huge portion of momentum is linked with Newton's second law, which that also we will see. But before that, note down all these points.
What is the second point you wrote for momentum changing?
That is, external force will be zero. If your momentum is changing, it means some external force is acting. That is, it is non-zero.
Okay.
Now see, can we start with Newton's second law? All have completed till here, understood till here?
Yes, ma'am.
Yes, ma'am.
Good. See, Newton's second law is related to momentum only. Now comes the actual topic about which the whole lesson is based on, that is force. Force is the basic topic of this lesson, which the whole lesson will be revolving around. Basically, momentum, you have understood the amount of motion in a body that is characterized as the product of mass into velocity. These two things are present. Now, if the momentum changes with respect to time, if the momentum changes with respect to time, let's say for 1 second momentum is something else, then for another 1 second the momentum has changed. So continuously we are seeing that momentum is changing with respect to time. As the time is elapsing, the momentum's value is being changed. Whether uniformly, non-uniformly, that is a different thing. But what we are noticing is the fact that momentum is changing with respect to time. Now the quantity that you obtain when the momentum is being changed with respect to time, that is what we call as force. Force is a very common term, a push or a pull. We say in normal language, in common language, we call it as a push or a pull. So this is what is meant by momentum. So Newton's second law of motion, basically, this is in relation to the measure of force. The first line says that relation to measure force. It will give you, Newton's second law will talk directly about force now. Introduction to inertia has been made. Now directly it will talk about force. Whatever is the force acting in your system, it is actually rate of change of momentum. This is written also. External force acting on a body is equal to its rate of change of momentum. Means, let's say change in momentum is delta P. Delta P is the change in momentum. Delta T is the change in time. So what will you say? What is the external force which is acting in your system? External force will be change of momentum per unit time, means rate of change of momentum. I have told you this earlier also. See, if something is changing with respect to position, Suppose a quantity is there which is changing with respect to position. As the distance is changing, the distance is increasing, the particular value is changing. Then we say it is gradient. But if a particular quantity is being changed with respect to time, like here momentum is being changed with respect to time. So we say this is rate. So there are two different words, gradient and rate. Gradient means something that is changing with respect to position, and rate means something which is changing with respect to time. So rate of change of momentum is what is called as the external force. External force actually gives you the measure of the rate of change of momentum. What is meant by the change of momentum means you have a particular initial value of momentum at an initial time. Let's say T1, this is T, some final time is there. So change in momentum will be final momentum minus initial momentum. Time duration will be final time minus initial time. Remember, in distance and displacement, we had seen the concept. If you have to calculate the average velocity, when you have to calculate the instantaneous velocity, sometimes you have to calculate the average acceleration, sometimes you calculate the instantaneous acceleration. There was a technique to differentiate between the two. I have told you, whenever you have a particular duration, 1 to 2 seconds, 3 to 4 seconds, 0.1 to 0.8 seconds, 2 p.m. to 4 p.m., a particular duration you are having, you calculate the change in the quantities like this. And we used to get average velocity, we used to get average acceleration. Remember, related here. Here you will obtain average force if a particular duration is given. But suppose a duration is not given. A time instant is mentioned to you. Exactly at 3 p.m. find out the force. Exactly at 4.066 seconds find out the force. A particular force is being given to you. A particular time instant is given to you. Not a duration, not a beginning or an ending, a particular second. That is what we call as instant, time instant. If time instant is given, then you calculate the instantaneous force, that is dp over dt. I hope you all are able to remember. In kinematics, we have done this concept. When we have average acceleration, remember?
Yes, ma'am.
So this is the same thing, but just remember we have to substitute this here. So this is instantaneous force. So perform differentiation in here. Now, one thing, see, F is equal to dp over dt we are having. This is the concept. We already know that momentum is mass into velocity. So if we substitute momentum as mass into velocity in this formula, what will we obtain? F external is dp over dt. So instead of momentum, I can write it as mass into velocity over dt. How do we differentiate? Differentiation we have revised it so many times, right? So if mass is constant, if a quantity is constant, we keep it out of the bracket. So mass, if mass is constant, so we can say F net or F external, this is equal to m dv over dt. Can anyone tell me what is this quantity that is being obtained now?
Acceleration.
Very good, Nisha. Yes, sir. Nice. This is acceleration. So we have ultimately the formula of force F external. This is equal to mass into acceleration. So a very common formula, F is equal to ma. I think 1 or 2 times I have used it before also in front of you all, where I have told you that we'll do it separately in detail. So this is actually your Newton's second law. This is actually your Newton's law of second law. Second law of motion, just with one condition, that your mass has to be constant. If a mass is changing, Newton's laws are not valid. You have different theories for that. Certain Einstein's theories are also given. Different theories are given where the mass is being changed, where the relative particles are taken. But that you do not have to do. For you all, every time the mass will be constant. If a different case is there, you will be able to integrate it and do, but that the quantity which will be varying could be your acceleration, your velocity, something else. Mass will be constant. And force is a vector quantity, very, very important quantity for all of you. Newton is its SI unit. You must have heard 5 Newton, 6 Newton somewhere written. So it's a vector quantity. SI unit is Newton. Like you must have heard of 5 Newton is acting on a body, 6 Newton is acting like this. So Newton is the SI unit. And CGS unit, remember, for force. Very less CGS unit conversions you have to remember. Like for energy, you have to remember 1 joule and 1 erg. For 1 Newton and 1 dyne, you have to remember. So as we'll go to work energy in part, that I'll tell you about energy. But right now, remember, 1 Newton is equal to 10 to the power 5 dyne. You all have done a question also with me in the first lesson where through N1 U1 is equal to N2 U2 from dimension analysis, we have actually found the value of this conversion. This was N1, this was U1, this was N2 U2. So N2 came out to be 10 to the power 5. This conversion, remember it. Note down all the points, then we'll practice 1 or 2 questions, basic questions from force. Newton's second law of motion.
Okay, you go back up.
See, this question says the body starts from rest and attains a velocity of 10 meter per second in 5 seconds. You all didn't answer this question. By now, you should be able to answer this. This is an easy question. Formula of force is F is equal to ma. Is acceleration given? A is missing. M is given to you, but acceleration is missing. You know the body starts from rest, means initial velocity is 0. It attains a velocity, means you know final velocity is 10 meter per second. Time is 5 seconds. Can't you find out acceleration? V is equal to U plus AT. This becomes 0. Yes, Harsha. Good. So acceleration will be velocity divided by time, that is 10 by 5 seconds, that is 2 meter per second square. Now your force will be mass into acceleration. Mass is 5, acceleration is 2. 10 Newton is the force. 10 Newton. Good. Note it down. One more question we'll do.
Ma'am, can you show the next question?
This says that a scooterist moving with a speed of 36 kilometer per hour, 36 kilometer per hour, we'll have to convert. Sees a child standing in the middle of road, he applies the brakes and brings the scooter to rest in 5 seconds. So again, rest means final velocity is 0. Your initial velocity is given as 36 kilometer per hour. Calculate average retarding force on the vehicle, mass is given. So same question, a similar question it is, with just the value is different. This you should be able to answer by now. Firstly, convert this because this is in kilometer per hour. 36 multiply by 5 by 18. So that becomes 2. 2 into 5 is 10 meter per second. Multiply by 5 by 18 whenever you have to find it out. Negative will also come, Sarah. Good. Magnitude is right. Negative will also come. How come your negative sign is not there? What is your acceleration? Your acceleration should be negative.
Yeah, minus
E is equal to u plus 80. Final velocity 0. Initial velocity is this 10 meter per second. Acceleration we do not know. Time is 5 seconds. What is our equation? V is equal to u plus 80. 0 is equal to 10. This is unknown. Plus acceleration 5a. So acceleration will be 5a will be minus 10. So acceleration will be minus 2 meter per second square. F is equal to ma. Mass is 300. Acceleration is minus 2. So force will become minus 600. Note down the solution quickly. Minus 600. Good, Harsha. Note it down, then we'll discuss. You people didn't attempt the test, only Siddhika has attempted. Last test also only she has attempted. This time also, did you all attempt it? Martin, Sarah, Harsha. Vectors came in your exam.
Yeah, I attempted.
You have attempted, Martin?
Yeah, ma'am.
Okay, Sarah and Harsha, what about you both?
I don't think so because at the time I guess I was having classes. It's at 11, so.
Okay. Fine, class. Note this quickly. We have time. We'll quickly discuss Newton's third law also. So at least the laws are discussed. See what is meant by Newton's third law. Newton's third law is very simple. Okay, first law was regarding inertia, second law was all this which we discussed, third law is very simple. Third law says that if, let's suppose these are two bodies which are in contact with each other, suppose this body is applying a force on this. So this body will also apply a force along the same direction, along the opposite direction. It means, suppose I have these two bodies with me. Suppose I have taken, let's say, two boxes and I've kept it on a tray. Will the two boxes move without any external force? No, the boxes do not move. Why? Because both of them, actually, whatever contact forces is being applied by one body is exactly being applied by second body. So they counterbalance each other and resultant is net force magnitude becomes zero and net force is zero. Right? So one we call as action, another we call it as reaction. So for every action, if this body is applying an action, reaction will also be generated. So for to an every action, there is an equal and opposite reaction. This is what is your third law. Nothing difficult in here. Suppose let me discuss this with you. Suppose this is one body. This is another body. This is body B. This is body A. Let's say the body A has applied a force which is FAB, means force on B because of FAB. Or let me write it reverse. FBA, force on B due to A. This is better. Accordingly, because with the same magnitude, one FAB will be applied, force on A because of B. It means you can say that force on A because of B is actually negative of force on B because of A. This is the Newton's law. For an every action, there is an equal and opposite reaction. Equal and opposite. Negative sign is telling you the opposite direction. This is what is meant by Newton's third law of motion, which you have to remember. They are instantaneous, means they occur at the same time. It's not like you have applied an action for a particular time and the reaction is being occurring after 2 hours. If this body has applied a force in this direction, immediately the reaction will be applied and both the bodies will remain in neutral position. Right? Both the bodies will remain in neutral position. It's not like this body has applied one force on body A and A is giving the reaction 3 hours later. No, they are instantaneous process. And why do not they cancel each other? If they are so equal in magnitude, then action and reaction should cancel each other. Difference is that if I have one body, let's say I have this particular one body. I have this body. Mass is M. One force is being applied here, one force is being applied here. If the body is not moving, this body is not moving. So I will say whatever forces are acting on the right hand side is actually balancing the forces acting on the left hand side. So F1's magnitude will be equal to F2's magnitude. Both the forces will cancel each other and the body will stay in neutral position. But if I'll tell you that on this body, force F1 is occurring, and on this body force F2 is occurring. Now will you say they will cancel each other? No, because they are the forces acting on two different bodies. Here also, look at the example above. Force FBA was acting on B, FAB was acting on A. This is the force FAB that is acting on body A. This is the force that is acting on body B. If two bodies are there where two different forces are there, how can you cancel them? We cancel the forces. No, even in one body only the same thing occurs. For example, this is a body. Downwards gravitational force is acting. One force is acting that is balancing it. So they will cancel each other force. The above force will cancel, the normal reaction will cancel the gravitational force. But if force is acting on one body, gravity is acting on another body, we cannot cancel both the things. That's why there is no cancellation in here despite having an opposite and equal sign. Clear, class? All the laws are clear to all of you or not?
Yes, ma'am.
Yes, ma'am.
Martin, Siddhika,
Yeah, ma'am.
Siddhika,
Yeah.
what about you, Siddhika? Martin, Harsha, and Sarah have answered. They are responsive. What about you, Siddhika? Clear. Good. If you have any doubts, you can ask. Quickly note down this one. Last, this is the Newton's last law. Class, text me done once you have written till here.